Chapter 2. Playing with numbers. Factors and multiples. Factors. If two or more numbers are multiplied together, each of the numbers is a factor of the product. Example. Since 1 multiply 7 multiply 5 multiply 3 is equal to 105. So, factors of 105 are 1, 3, 5, 7, 15, 21, 35, 105. Properties of factors. 1 is a factor of every number. Every factor of a number divides the number exactly. The number of factors of a number is finite. Multiples, the product of any two numbers, is a multiple of each of the two numbers. Examples. 1. 7 multiply 8 is equal to 56. 56 is a multiple of 7 and 8 both. 2. 85 multiply 1 is equal to 85. 85 is a multiple of 85 and 1 both. 3. 1 multiply 79 is equal to 79. 79 is a multiple of 79 and 1 both. 4. 1 multiply 10 is equal to 10. 2 multiply 10 is equal to 20. 3 multiply 10 is equal to 30. 4 multiply 10 is equal to 40 and so on. So the number 10 has many multiples and it can go to infinity. Properties of multiples. Every number is a multiple of the number itself. Every number is a multiple of 1. Every number has infinite multiples. Odd and even numbers. Odd numbers. The numbers not divisible by 2 or not multiples of 2 are called odd numbers. For example, 1, 3, 5. Even numbers. The numbers which are multiples of 2 or divisible by 2 are called even numbers. For example, 2, 4, 6. Test of divisibility. Divisibility test by 2. A number is divisible by 2 if the ones digit is 0, 2, 4, 6 and 8. Examples. 10 is divisible by 2 since 0 is present in one's digit. 16 is divisible by 2 since 6 is an even number present in one's digit. 8 is divisible by 2 since 8 is an even number. Divisibility test by 3. A number is divisible by 3 if the sum of digits of the number is divisible by 3. Examples. Number 15 is divisible by 3 since sum of the digits of the number is 1 plus 5 is equal to 6, which is divisible by 3. Number 984 is divisible by 3 since sum of the digits of the number is 9 plus 8 plus 4 is equal to 21, is divisible by 3. Divisibility test by 4. A number is divisible by 4 if the number formed by the last two digits is divisible by 4. Examples. Number 116 is divisible by 4 since the number formed by the last two digits is 16 and 16 is divisible by 4. Number 4,56,748 is divisible by 4 since the number formed by last two digits is 48 and 48 is divisible by 4. Divisibility test by 5. A number is divisible by 5 if the number in the ones digit is either 0 or 5. Examples. Number 150 is divisible by 5, since the number in the ones digit is 0. Number 855 is divisible by 5, since the number in the ones digit is 5. Divisibility test by 6. A number is divisible by 6 if the number is divisible by 2 and 3 both. Examples. Number 234 is divisible by 6, since 234 is divisible by 2, as it is an even number having 4 in ones place. 234 is also divisible by 3, as the sum of the digits 2 plus 3 plus 4 is equal to 9 is divisible by 3. So, 234 is divisible by 6, since it is divisible by both 2 and 3. Divisibility test by 8. A number is divisible by 8 if the number formed by last 3 digits is divisible by 8. Examples. Number 72,984 is divisible by 8. Since the number formed by last 3 digits, that is 984, is divisible by 8. Number 56,70,000. 1,872 is divisible by 8, since the number formed by last 3 digits, that is 872, is divisible by 8. Divisibility test by 9. A number is divisible by 9 if the sum of the digits of the number is divisible by 9. Examples. 24,561 is divisible by 9 since the sum of the digits of the number 2 plus 4 plus 5 plus 6 plus 1 is equal to 18 is divisible by 9. Number 7,89,651 is divisible by 9, since the sum of the digits of the number 7 plus 8 plus 9 plus 6 plus 5 plus 1 is equal to 36 is divisible by 9. Divisibility test by 10. A number is divisible by 10 if the digit in the ones place is 0. Examples. Numbers 10, 20, 30, 40, 50, 100, 1000, 10,000, etc. all have 0 in the ones place. So, all of them are divisible by 10. Divisibility test by 11. A number is divisible by 11 if the difference between the sum of its digits in odd and in even places is either 0 or a multiple of 11. Examples. Consider the number 28,457. The sum of the digits in odd places 2 plus 4 plus 7 is equal to 13. The sum of the digits in even places 8 plus 5 is equal to 13. Difference between the sums 13 minus 13 is equal to 0. So the number 28,457 is divisible by 11. Consider the number 30,789. The sum of the digits at odd places 3 plus 7 plus 9 is equal to 19. The sum of the digits at even places 0 plus 8 is equal to 8. Difference between the sums 19 minus 8 is equal to 11. So, the number 30,789 is divisible by 11. Prime and composite numbers. Prime numbers. The numbers which have only two factors 1 and the number itself are called prime numbers. Examples 2, 3, 5, 7, 11, 13, 17, 19. 2 is the smallest prime number. Composite numbers. The numbers which have more than 2 factors are called composite numbers. Examples: 4, 6, 8, 9, 10, 12. 4 is the smallest composite number. A Greek mathematician Eratosthenes derived a method to find prime numbers from 1 to 100 in the 3rd century BC. The method is explained below. First, prepare a table from 1 to 100. Now follow the steps. Step 1. Cross 1 as it is neither a prime number nor a composite number. Step 2. Encircle 2 and cross all multiples of 2. Step 3. Encircle 3 and cross all multiples of 3. Step 4. Encircle 5 and cross all multiples of 5. Step 5. Encircle 7 and cross all multiples of 7. Now, encircle the numbers which are not crossed. So, the encircled numbers between 1 to 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. These are the prime numbers from 1 to 100. Coprime numbers. Two numbers that have only 1 as a common factor are called coprime numbers. Therefore, pairs of prime numbers are coprime numbers. Examples: 2, 3, 3, 5, 5, 7, and so on. Twin prime numbers. Two prime numbers with a gap of only one number are called twin prime numbers. Examples: 3, 5, 5, 7, 11, 13, 17, 19, 29, 31. How to find out a number is prime or not? Let us find out whether the numbers 31 and 83 are prime or not. Step 1. Find out a square number immediately after 31. It is 36, since 36 is equal to 6 into 6. Step 2. The prime numbers below 6 are 2, 3, 5. Step 3. Find out if the number 31 is divisible by 2, 3 and 5. It is not. So, 31 is a prime number. Similarly, let us work out for 83. Step 1. The square number immediately after 83 is 100. 100 is equal to 10, multiply 10. Step 2. The prime numbers below 10 are 2, 3, 5, 7. Step 3. Find out the number 83 is divisible by 2, 3, 5 and 7. It is not. So, the number 83 is a prime number. Common factors and common multiples. Common factors. Take two numbers, say 24 and 36. Find the factors of the numbers. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. So, the common factors of 24 and 36 are 2, 3, 4, 6 and 12. Common multiples. Take two numbers, say 4 and 6. List some multiples of 4 and 6. Multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32. Multiples of 6, 6, 12, 18, 24, 30, 36, 42, 48. So, the first two common multiples of 4 and 6 are 12 and 24.